I'm Anatasha Nabilah binti Suhaimi.
Hi, I'm Che Ku Rossuhaila binti Che Ku Ramli.
I am Nur Hannani binti Mohd Asri.
And me, Nur Hannani's Faqihah binti Abdul.
In this video, we are going to present our chosen topic, logical implication, for the mathematical logic and proving techniques subject. Implication is a type of relationship between two statements or sentences. The second statement is a logical consequence of the first statement, which is also called as hypothesis. Logical implication is defined as if A and B are two logically expressions, and if A implies B is tautology, which means all the conclusions are true, we say that A logically implies B. We use the arrow to the right symbol to represent the logically implies and add a cross to it to represent the otherwise, which is not logically implies. Truth table is used to prove a conclusion as tautology, then said to be logically implies. An argument consists of a statement or finite collection of statements called hypothesis and a statement called conclusion. An argument is valid if the conjunction of its premises logically implies the conclusion.
Okay, now, to be more clear, let me show you how we're gonna answer logical implication questions. First, let's look at example 1. Determine whether the following expressions are logically implied or not by using the truth table. P implies Q and P and negation P or Q. So we have to find P and P implies Q implies with P and negation P or Q. It's a simple question. First, we determine how many statements we have here. It's two statements, which is P and Q. So we make column for P and Q and write the possibility. There are four possibilities if we have two statements. It is true, 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 false, false, true, and false, false. If you look at the questions, there are P implies Q. So we have to make column for that. So P implies Q, true implies true become true, true implies false become false, false implies true become true, and false implies false become true. Next column is P and P implies Q. We determine it and get true, false, false, false. Next, we make a column for negation P or not P, which is false, false, true, true. Then column for negation P or Q. True, false become true, false, false become false, true, 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 and false, true become true. Next, we must determine P and the negation P or Q. True, true become true, true, false become false, false, true become false, and false, true become false. And after that, the last column, P and P implies Q, implies with P and negation P or Q, and we get true, 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 true. Since the expression is tautology, therefore P and P implies Q logically implies with P and negation P or Q.
Next, example 2. Determine whether P implies Q and Q and R or Q and negation R and R are logically implied or not by using the truth table. Set our truth table with Q, R, P. Q, true, 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 false, 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 false. R, true, true, false, false, true, true, false, false. P, true, false, true, false, true, false, true, false. Next, P implies Q, true, 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 false, true, false, true. Then negation R, false, false, true, true, false, false, true, true. Afterwards, Q and R, true, true, false, 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 false. Q and negation R, false, false, true, true, false, 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 false. Q and R or Q and negation R, true, 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 false, 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 false. P implies Q and Q and R or Q and negation R, true, 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 false, 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 false. And the last, P implies Q and Q and R or Q and negation R implies R, true, true, false, false, true, 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 true. So the conclusion of this question is, since P implies Q and Q and R or Q and negation R implies R is not a tautology, then P implies Q and Q and R or Q and negation R is not a logically implies R.
For example 3, determine whether the following expression logically implies or not by using the truth table, which is P implies R and Q implies R and P or Q implies R. In that circle, it states PQR. So for P, it will be true, 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 false, 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 false. Q, true, true, false, false, true, true, false, false. And R, it will be true, false, true, false, true, false, true, false. When P implies R, it will be true, false, true, false, true, 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 true. Q implies R, it will be true, false, true, 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 false, true, true. So for P implies R and Q implies R, it will be true, false, true, false, true, false, true, true. P or Q, it will be true, 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 false, false. When P or Q implies R, it will be true, false, true, false, true, false, true, true. So for P implies R and Q implies R, implies P or Q implies R, it will be all true. The conclusion, since P implies R and Q implies R implies P or Q implies R is tautology. Therefore, P implies R and Q implies R is logically implies to P or Q implies R.
In sum, if a statement is tautology, it is said to be logically implies, while if a statement is not a tautology, it is said to be not logically implies. To find whether a statement is tautology or not, we use truth table. We'll have it as tautology if all the conclusions turn out to be true. That is all from us. Thank you.